Today's lesson is 4.2, applying congruence in triangles. Two geometric figures are congruent if and only if they have the same size and shape. Right? So, for example, on the left side, we've got congruent trapezoids, and they all are the same exact size and shape. Whereas on the right side, we've got three different size triangles. Some are either different size or completely different. Right? We've got two acute ones here, and then the third one's obtuse, right? So clearly not congruent. And what we need more specifically is that each angle is congruent to another angle here, and each side is congruent to a side. And so the two corresponding figures, all parts of one figure are congruent to the corresponding parts of the other figure. Right? So when we've got two congruent shapes, right, each angle we have in one, like angle A, is going to correspond to an angle in the other congruent figure. So that means that our corresponding sides and corresponding angles are congruent. It'll make a little more sense when we see a diagram in a moment. But when you write a congruent statement for two polygons, you need to list the vertices in the same order. Meaning, if triangle ABC is congruent to triangle XYZ, just by how I wrote that statement, angle A and angle X are congruent. Angle B, angle Y would be congruent. And angle C, last one, and angle Z would be congruent just based on their position in the statement. Also, then our sides are congruent, but that's only the angles. Our sides would also be congruent, such as AB is congruent to XY, BC congruent to YZ, and lastly, first and last, AC and XZ. Right? So the order in which they're listed is important. So when we see that two triangles are congruent, you can't just say, oh, those three letters, the other three letters. Right? It has to be in a particular order. For example, in this one, we've got triangle ABC and triangle FAD, and they are extremely labeled, right? Angle A and F congruent, angle B and E congruent, angle C and D congruent, as well as BC, EB, AB, FE, and AC, FD. So our statement could be triangle ABC congruent to FED, or you can list it other way. What if someone else started with B and went this way? BCA congruent to EDF. Right, so there's probably about, I think I did the math, about 6 different ways we can list those as congruent. But again, this is what they meant, corresponding angles congruent. Color-coded here for you, they generally won't. Right? Corresponding sides, and I already mentioned all of them. Order matters. Next, it says write a congruent statement for the triangles, so that's part 1. Part 2, identify all pairs of congruent corresponding parts. Mouthful, right? Now, it seems like, oh, we got to write our congruent statement first. However, whenever I do this, we generally make it easier on ourselves if we're going to list out for part 2, what are my angles that are congruent? All right, this is going to make it easier. So starting, listing my angles that are congruent. So I'm going to start here with angle K. Angle K is 1 arc mark, so S is congruent to that one. So angle K congruent to angle S. Next, we'll go down to 2. Right here, L has 2 marks, and R has 2 marks. So notice they aren't the same orientation. Right, it's the one on the left that went down, but on the one on the right it goes up. And then what's our last letter left? Triangle 1, we've got angle J with 3 marks, congruent to angle T with 3 marks. And now, for part 1, because I need triangle blank, congruent to the other triangle, I just take this order right here, triangle KLJ, going down that left side, is congruent to, now going down the right side, SRT. So that way that guarantees that K and S congruent, because I just did that, L and R congruent, J and T congruent from my angles. Lastly, we can't forget the sides, right? We did angles, we did part 1, now the sides. just to finish it off, right? We got JK and SP are congruent. We got KL and SR congruent. And then lastly, we got JL and RT congruent. If you have questions, let me know. But that's, again, very important in this whole chapter and beyond. Next one, in the diagram, DFG quadrilateral is congruent to SPQR quadrilateral. Find X and Y. So first off, I recommend finding where's your X. Right, so where's X located? I've got it in two spots. It's here in QR and it's angle Q. Now, going back to this right here, where is QR? QR is my last two letters. So QR equals FG, because they're the last two letters, or congruent, right? So 2x minus 4 here must equal 12 feet. That's why I did this statement here. So 2x minus 4 equals 12, and I can solve for x. Plus 4 to both sides, 2x is 16. Divide by 2, x is 8. So x is 8, solve for x. Next, Q angle also had x, but has y as well. So what other angle corresponds with Q? Right, so third letter is going to be DEF. Angle F and angle Q are equal. Right, again, just stating the obvious here in the math, but that means 68 degrees equals 6y plus x. 6y plus, we already know 8, x is 8, so I just plugged it in. That equals 68. Solving, subtract 8 from each side. 6y is 60. And so divided by 6, y is 10. And so my final answer is x is 8, y is 10. So that my answer is right next to each other in a box. Next, if you divide the wall into blue and orange segments along JK, will the sections of the wall be congruent? So first I'm going to look at congruent marks. We've got 1, 2, 3, and then the middle part. So I don't see a mark, but this part right here is used in both. This is where that reflexive comes in. JK congruent to itself, right? Sounds like a common sense thing, but that's reflexive. We'll see that quite a bit more starting this chapter. So those are congruent. So my sides are all good. Next, what about angles? Okay. Now I don't see parallel marks. However, perpendicular, 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 perpendicular. So I've got two sets of right angles. These two add up to 180. So the lines on top and bottom must be parallel. And therefore, 3 and 2 are alternate interior must be congruent. And 1 and 4 also alternate interior must be congruent. So writing that out, 1 congruent to 4, 2 congruent to 3, by alt interior angles. And now, because I have all angles congruent, right, I got right angles, I've got these parallel angles, all sides are congruent, yes, the sections are congruent. Next, identify all pairs of congruent corresponding parts and solve for x. Now, a little bit of goof in the instruction, but generally they'll tell you the shapes are congruent, then you have to find them, because not all shapes are going to have congruent corresponding parts. So, just kind of pick away. We'll see we got 2 right angles and then going the long leg. That's going to follow 2 right angles, long leg. So, because I can't do all my angles at once like I did previously, this is going to be, right, angle A and angle C are congruent. Angle B and angle D are congruent, all right angle congruent. And then keep following. Angle G congruent to angle E. And lastly, angle H congruent to angle F. My congruent side's getting a little weak here. I'm going to straighten them up. with that, that was just our segments. Technically, we can now do all, our angles, and now we can do all segments, right? So AB and CD congruent. And then we got BG congruent to DE. Just kind of working our way down here, actually. GH congruent to EF. Lastly, first and last, AH congruent to CF. And lastly, solving for X, right? We've got angle H, which is right here. This thing we're using, we've got 4X plus 5 equals angle F, which is 105. Now this one's a little bit simpler than it seems, because that's the only pieces on my quadrilateral that are labeled. So minus 5 from both sides, 4x is 100, divided by 4, x is 25. Okay. Next, we've got third angles theorem. If two angles are congruent in one triangle, congruent to another triangle's two angles. So in the example, B and E congruent, A and D congruent. By what's left over, we know the last angle, C and F, must also be congruent, right? Because again, these all add up to 180, and if we substitute it, we get C and F are left over, must equal each other. So, starting off here, we've got find BDC, right? So BDC is this angle right here. We want the large angle. How do we solve it, right? We've got triangles add up to 180, and we've got congruent marks here. These two are congruent. This is also 45. These two angles are congruent, so this is 30. And so we've got this large triangle here is equal to this large triangle over here. Right? They both have the same angles, 45, 30, and then this large obtuse angle. So we've got, again, kind of draw it separate for a second. You can see it something like that. We've got 30, 45, and then this angle that has 30 as part of it. So 30 plus 45 plus x, so we just want that whole BDC, you can see that now, is 180. 30 plus 45 is 75, so we're subtracting that from each side. And that large angle is 105, is angle BDC. Next, proving that theorem. It says 5 steps. Might go a little quicker through this proof. But again, given we've got a bunch of angles congruent, A and D are congruent, B and E are congruent. And notice, when we use variables like this, we're proving it for all cases, not just for one. Right? We didn't have an angle measure that it worked true. We've got a bunch of a given here, so we're probably just going to start with the triangles add equal 180. So we might need more space for that. A plus B plus C is 180, and so is D, E, and F. Sorry, we're kind of cutting off F at the moment. E is there. But D, E, and F also add equal 180. Okay. Well, we got two 180s. That's our hint. We're probably going to transitive. We got triangle, sum, theorem. So the next step is exactly what I just said. We're transitive or substitution. Right? I know some people love substitution, but either way, transitive property of equality, so POE tells me ABC equals DEF now. Missing a bunch of M's, but that's okay for measure because we're not going to have any numbers here. And now the way to finish this is to substitute. You get to pick what you want to substitute. I'm going to plug D and E in for A and B. So now I plugged in here and here. So DE plus C equals DE plus F. And then we're going to subtract what is in common. So this one has to be substitution. It cannot be transitive because we substituted into the middle of an equation. So that one is not an optional transit. And then because we both have D and E, you subtract those two pieces, and what's left? Angle C equals angle F. And we subtracted D and E from both sides. So subtraction, EOE. And so that's how that proof looks. Again, not too much use of the diagram, just to tell you that it's triangle sum theorem. And yep, the proof is congruent symbols, but equal and congruent are the same. We're not counting that as a step. And so we're at 5 steps for that. Last one. Now, deep breath. We won't be proving like this for long because the next lesson is a shortcut on how to do this proof because we have trigonometry, the study of triangles, that makes this a little bit easier for us. But here we've got the whole diagram is marked with congruent segments, AD and BC congruent, CD and AD congruent. We've got angles congruent, ACD and CAB, CAD and ACB, congruent. Right, so we got all these congruent parts because in this lesson we need 3 sides congruent to 3 sides and 3 angles congruent to 3 angles to have congruent. So that's the only way we can get here. Next lesson, that'll be we only need 3 sides or less. So filling in what we have given here. And it's just what are a couple ways we can prove things are congruent. Have a space there. It's all finished. Go on. Basically pasting the given there, but we're not in space. Well, we just learned that if we have 2 angles congruent, the third one, 2 angles, sorry, the third one must be congruent. Fortunately, because there's only one angle at B, we can say angle D and B are congruent. But there's only one angle here, one angle here. The other ones require 3. That is called third angles theorem. We have the first 2 congruent and the third angle is congruent. Lastly, we've got all 3 angles, pairs are congruent. We're missing this. That one is AC congruent to itself is reflexive. Right? Something equals itself is reflexive. EOC for we're congruent. And now we've got 3 sides congruent and 3 angles congruent. So our triangle ACD and CAB are congruent by definition of congruent. It's really polygons, but you'd say congruent triangles. Right? And that is that. Okay. So lastly, congruent triangles can be reflexive, symmetric, and transitive. We may use transitive once on this, but we really don't use these last ones much at all. And that wraps up today's lesson on 4.2. Look for homework on Google Classroom.